Section 7.1, Inverse Trigonometry. Keep in mind from a previous unit how we discussed what inverses mean. In tip number 1 here, f inverse of f of x is equal to x. The inverse and the original function cancel each other out. For every x in the domain of f, and also the other way around, we can say f of f inverse of x is also equal to x for every x in the domain of f inverse. Tip number 2, a reminder, domain of f is really the same as the range of f inverse. And likewise, the range of f is the domain of f inverse. Number 3, the graph of f and the graph of f inverse are reflections with respect to y equals x. If you recall from our previous unit, if we have y equals x here, whatever occurred on one side was just a reflection on the other side. Those were the inverses. If a function y equals f of x has an inverse function, then the equation of the inverse is x equals f of y. Keep in mind all you're doing here is switching x and y. And so the solution of the equation would be that y is really the same as f inverse of x. Let's take a look at our sine graph here. Based on the definition of a one-to-one function, the graph of the sine function below, if we try to make it one-to-one, remember informally what we're saying is that it has to pass the horizontal line test. And if we try the horizontal line test, you can see that this is not going to have an inverse function because it passes our horizontal line multiple times. So it is not a one-to-one function and therefore does not have an inverse. Okay? So that's basically what this is saying here. So how can we take the inverse of a sine function? Well, if we need it to pass the horizontal line test, we can only have this graph pass the horizontal line at one location. So we don't want the extra locations. We can't have this part of the sine graph. We can't have this part of the sine graph. What we're essentially doing is we have to restrict the domain. And the way that we restrict the domain, if you recall from our previous unit, when you discuss how to even find angles of measurements of our unit circle, keep in mind that we have the initial ray right here, and then from there you either go counterclockwise or clockwise to get to some terminal ray, and that would give you some angle measurement. So basically we do need to start at the value of 0 degrees or 0 radians, and so if this is our starting location, we always want to pass that horizontal line, and as you pass that horizontal line, the one spot where you start not passing the horizontal line test would start to be at this location here. You can see now it would not pass the horizontal line test. So we need to stop it at the value of pi over 2. And then if you actually backtrack your other way around, going clockwise, then you can still pass the horizontal line test. But the moment that you don't pass the horizontal line test, right here, we need to restrict the domain again. So I cut it off right here. And that would be at the value of negative pi over 2. So we need to restrict our domain from negative pi over 2 to pi over 2 for the inverse sine function. Okay, moving on to the next page. So how is the inverse of y equals sine of x notated? Well, as we discussed when working with inverse functions, what you can just do is switch x and y. So x is equal to sine y, just like that. And then if you really wanted to, and then remember that you wanted to solve for the value of y. So the way you solve for y is you need to get rid of this operation, this sine operation here. And the way we can do that is by doing its inverse sine. It looks like this, sine inverse of x. Very similar to how we discuss how this is the inverse f of x. So keep in mind it's not it is not an exponent. So sine inverse of x is not the same as 1 over sine x. Keep in mind that it really just implies inverse. Okay? So the domain of the inverse function is the range of y equals sine of x, and the range of the inverse function is the domain of y equals sine of x, just like all of our other inverse functions. Okay? All right, so y equals sine inverse of x means x equals sine of y, So basically you see the idea here. Our original function in red would be right here, and because it's a reflection across the line y equals x, you can see that whatever got mirrored, whatever's over here now gets mirrored over here in quadrant 1, and whatever was in quadrant 3 over here now gets mirrored over down below. So the purple line represents your inverse function. This is going to be y equals sine inverse of x. Okay. All right. Keep in mind that it is also restricted. Notice that the endpoints are stopping right there. We just have little points there. Same thing here. We just have little points there. Okay. What also used to have the ordered pair pi over 2 comma 1 is now the ordered pair 1 pi over 2. On the other side, negative 1 negative pi over 2 got mirrored over from the original point of negative pi over 2 negative 1. Let's take a look at some equations here. Solve cosine of x equals negative half. We're going to work with degree format here. So what this is basically asking us is what angle gives cosine of x to be negative half? Okay, you're basically looking for the x value. So keep in mind that the x value is giving you an angle. You want to find the angle that gives you negative half. So if you think about this on the unit circle, the time that you get a cosine to be negative, if you recall, we have the mnemonic ASTC. Cosine would give us negative in quadrant 2 and also quadrant 3. So we're looking at some measurements that give us values in quadrant 2 and quadrant 3. And if you think about, as we had learned about the unit circle in the previous unit, think about when cosine actually gives you that value of half, and hopefully what you're recalling is that that x value is giving you a measurement of 120 degrees. And you also have another measurement over here. Remember that since half is giving you that reference angle of 60 degrees, we also have another 240 degrees. Okay. Now, remember that because x can take on any value, you can't go all the way around, right? Find a full revolution and get any coterminal values as well. So with that regard, what we need to do is remember that we can add a full circle to it. So add 360n to it to determine any other angle measurements where n is an integer. Okay, so that would be your answer there. Okay, now if you were to actually do this in your calculator, let's go ahead and take a look at that. Calculator. Oops, wrong Desmos. In our calculator, I'm going to go ahead and do the inverse cosine. Inverse cosine of negative half. That's what we had, negative half. There we go. And look, we get that value of 120 degrees. And that's it. We ended up not getting the two answers that we had found before. So if you recall, we had 120 degrees and 240 degrees. But in the calculator, it said that if we wanted to find cosine of x to give us negative half, what we did was we had arc cosine or inverse cosine both sides, like this, simply, like this. Okay, and we ended up getting that x is equal to cosine inverse of negative half, but in the calculator, that gave us a value of only 120 degrees. So then the question becomes like, why does the calculator only give one answer? Only give one answer. That'd be a good question to try to answer. Let's take a look at the next problem. Maybe we can figure it out in this problem here. So sine of x is equal to negative root 2 over 2. Now we're looking at it in terms of radians. Recall from our example 1, what we want to do is think about it in terms of where does sine give you that negative value? And using your mnemonic, remember that sine is going to give you negatives in quadrant 3 and quadrant 4. Okay, well, if it gives us quadrant 3 and quadrant 4, root 2 over 2, if you recall, think about your reference angles here. That's going to be the value of 45 degrees or pi over 4 radians. So if we want to get into quadrant 3 or quadrant 4, then that's going to be the values of 5 pi over 4 and 7 pi over 4. And then as we had seen in problem number 1, we can also find any coterminal values. So add on a full revolution, 2 pi and n, because the n will represent some integer value where you'll always get one complete revolution, one full circle. Okay, so you actually have two answers there, 5 pi over 4 plus 2 pi n and 7 pi over 4 plus 2 pi n. Again, if we try this in the calculator, let's go ahead and do that. We're going to do sine inverse of negative root 2 over 2. There we go. And we get negative 45. Oh, that's in degrees, but if we want radians, there it is, negative 0.785. If you just want to make sure you have the correct answer here, let's see, what is that really the same as? If we tried pi over 4, let's see here, where's pi? Did I miss pi? Oh, pi over 4. Pi over 4 does give us that value of 0.78. So we can see that this basically gives us the equivalent of negative pi over 4. Negative pi over 4. Wait, let's go back. That doesn't even sound right at all. In our calculator, when we found that sine of x was equal to negative root 2 over 2, and then we had inverse signed both sides like this, we ended up getting a value, sine inverse of negative root 2 over 2 of negative pi over 4, or negative 45 degrees. But that wasn't even one of our answers that we saw up above, that 5 pi over 4 and 7 pi over 4. So again, like, why don't we get those two answers? And why, in this case, is it not even the same answer? We're not even getting that 5 pi over 4 or 7 pi over 4. Instead, we got a negative pi over 4. Well, the answer comes back to what we had just talked about in the very beginning of the video. How, when we look at sine, you need to think about it in terms of how you have to restrict the domain. Your answers can only lie between negative pi over 2 and pi over 2. Once you have passed that region, the inverse function no longer exists. So you can only have answers contained within these values here, negative pi over 2 and pi over 2. So for that reason, when we take a look at our answers here, if we restrict the domain of sine to negative pi over 2 and pi over 2, take a look at my unit circle now. I'm only going to have values in this purple semicircle. And the only values that can exist are the ones that take place right here in quadrant 4. Quadrant 3's answers do not exist. They are not contained within my purple semicircle of negative pi over 2 to pi over 2. So the only answer we can take is this spot right here, and the only way we can get there is working our way backwards, and working our way backwards by negative pi over 4. Okay? So keep in mind that when we work with inverse sine, we need to always think about them as functions. And so you'll hear me say a lot, I might have already said it in the video, that sometimes you can say the arc trig function, like arc sine, or even arc cosine. But really what this means is it's the inverse trig function. So it's the same thing as saying sine inverse or cosine inverse. They mean the exact same thing. And what it allows you to find, when you find arc sine, what is the answer? It's always giving you an angle. It gives an angle measurement. Okay, as you can see from the answers that we have seen, right? These are always angle measurements that you are finding, and keep in mind that it has to be maintained within the inverse function. If you want it to be a function, be aware of restrictions. Be aware of inverse restrictions. Okay, or I should rather rephrase that, inverse domain restrictions. The inverse domain restrictions. Okay, so we'll stop this video here.